Let's do another one of these Fibonacci problems that has another little different twist with it. Let's look at number 23. And again, I've not put everything from 23 sitting here on the paper. If you haven't read 23, stop the video now and please read it first. Okay, there's two things that are different about this particular problem from the previous ones. Well, one of the things that's different is it says instead of having one pair or having 4 pairs of rabbits being begot, it's got 3 pairs. But the thing that's the new twist is it says that instead of not being fertile for the first month, these are now not fertile for the first 2 months. So what happens is in the first month you have 1 pair, and in the second month you still have 1 pair. In the third month you have that 1 pair, but the original pair begots a set of 3. The next month you have the original pair, and the original pair also begots a set of 3. These 3 are still here, and they're not having any babies yet because it hasn't been 2 months yet. So you notice what this pattern is doing. It's going 1, 1, 1, 4, 6, 7. Okay? Now, if we're going to find the recursive formula for this, the recursive formula for this one has to be, using the rule that still none of them die, we have all the ones from before. Plus we're going to multiply 3 times, not how many were there the month before that, but 2 months ago. So instead of being n minus 2, this one's going to be n minus 3, and our rule is going to work for all of the n's starting in the 3rd month. Notice what this means, though, is now what I have to have is initial conditions for s sub 0 through s sub 2. So that's how we come up with the formula. And we need all of this for the formula. We need to have this saying where it starts at greater than or equal to 3. And we need to have these many initial conditions. We need to have the 3 because we have to be able to look back 3. Part B asks us to figure out how many rabbits there are in those first months up through month number 5. Well, we know 0 through 2 is pretty easy because that's part of those are all the basis cases, or the seeds. So r sub 3 is now going to be r sub 2, the month before it, plus 3 times r sub 0. We have to look back not just 1 month, but 2 months. So it's really going back 3 months there. So r sub 2, you see, is 1. And if we do 3 times r sub 0, which is 1, these come together to give us 4. Now here, r sub 3 was just calculated to be 4 plus 3 times r sub 1, going back to here. This one's going to be 4 plus 3. This one's going to be 7. R sub 5, well, we're going to have the ones we had before, which is going to be 7, plus another 3 times 1 to give us 10 in R sub 5. Now, question C, I think they're just being mean again when they say figure out how many you have at the end of a year. How about for us, we just figure out how many we have at the end of 6 months. So how many rabbits are there at the end of 6 months? Well, you notice the next time, what we're going to do, r sub 6 is going to be r sub 5 plus 3 times r sub 3. Well, we just calculated 10 here, and now we're going to see this is where this one starts exploding. This one's going to be 3 times now r sub 3, which is 4. 3 times 4 is 12 plus 10 makes this one 22. And again, since it asked how many rabbits are there, don't fall into the trap of answering 22, because that's how many pairs there are. You have 44 rabbits. Do expect to see a problem like 22 or 23 on the test.